Yeah, so hello everyone. Welcome to the paper discussion, part 10. I'm going to discuss the solution of physics. Yeah, as per Coulomb's law, force between two charges is force between two charges is K Q1 Q2 by R square. So in this question, charges are of same magnitude, so we can write K Q square by R square. Now what they are saying, ki charge new charge become Q by 2 and separation between them is doubled, means 2r. So f dash become k q dash square upon r dash square. So just put the value q by 2 up square upon 2r whole square. So what you will get, kq square, we will get 1 4 and 1 4 due to this term 4 r square. So what we are getting, kq square by 16 r square, and the value of kq square by r from this equation is f. So f dash become f by 16. So f by 16 is the correct answer. So in this question, a point charge is placed at the origin, and what we have to find electric field at this point 30 comma 30. So this is the negative charge, so electric field is towards the charge, and we know due to the point charge electric field is k q upon r square, right? So if this is 30 comma 30, then this distance become 30 root 2 centimeter by using Pythagoras theorem. So simply just putting the value 9 into 10 power 9, which is the electrostatics constant. Charge is given 8 into 10 power minus 9 upon r square. So r is how much? 30 root 2. And since it is in centimeter, so we have to convert it into meter. This is square. Okay, so what we are getting, the magnitude become this become 9 into 8, this will cancel out. So from here we will get 900 into 2 into 10 power minus 4. So 9 it become 100, it become 100. So this become 4. So what we are getting from here, 400. So electric field is 400 Newton per Coulomb, and the direction is towards the origin. So we have to write in the vector form, then we have to multiply magnitude with the direction also. The direction is root I cap minus j cap, and since is a unit vector, so we have to add this. So what we are getting then, minus 200 root 2 I cap plus j cap. So which option is correct? Option C is correct. Yeah, in this question, mass of Earth is given and radius of Earth is also given. So we know potential inside a solid sphere is given by minus gm by 2r cube in bracket 3r square minus small r square, where small r is a distance from the center. Suppose this is any solid sphere whose radius is r, and we are finding potential at here at distance r from the center. So given in the question, it is given r is r by 2. So just simply put the value of r, small r, you will get the value of potential 3r square minus r square by, it become r square by 4. So from here you will get gm upon 2r square in bracket 12 minus 1, which will give you 11 by 4 r square. So simplifying it, you will get V in equals to minus gm 11 gm by 8 r. So this is our answer. So in this question, I suggest you to remember this formula, otherwise it will take a lot of time to drive it. In the same type of formula we have in electrostatics also. Okay, moving to the next question. So the charge flowing through a resistor is given. This is the equation. Charge is AT minus BT square. So what they are asking, the total heat produced in resistor R in the time, the total heat produces in R by the time current ceases. Current ceases means the time at which I become 0. But in this question I is not given, but we know I is what? I is rate of change of rate of flow of charge. So simply differentiate it, d by dt at minus bt square. So from here what you will get, I is a minus 2bt. So now we have to find the time at which current is 0. That time is when current is 0, put it equals to 0. From here you will get time is a by 2b. Now the question is how to calculate heat produce. Again, we know heat produced across resistor is dH equals to I square R dt. Okay, because I square R is a power is a rate of change of energy. So total heat you have to integrate it dH from where to where, at starting from 0 to at time t by 2b. So just put the value of I is a minus 2bt and dt whole square r. So it become r k. Put the value of limits also, 0 to a by 2b. Here you will get a square plus 4b square t square and minus 2abt dt. So on integrating each term, what you will get, h equals to a square, r is common, a square t plus 4b square t cube by 3 minus 2ab, integration of t is t square by 2, and limits of integration are from 0 to a by 2b. So on putting the value, what you will get, just put the limits, r is common here, you will get a cube r, sorry, a cube by 2b plus a cube upon 6b minus a cube upon 2b. So this term will cancel out. What we will have, I'm writing here, h become a cube by 6b. So which is the correct answer? Option B is the correct answer. In this question we have to find the electric field at point P. Before that you have to remember electric field due to the wire is due to the finite wire is just perpendicular and parallel component. So perpendicular component perpendicular to the wire is uh, k lambda by r in bracket sine theta 1 plus sine theta 2, and E parallel become k lambda by r cos theta 1 minus cos theta 2. You have to remember this formula. So if one end is at infinity, this end is at infinity and point is here. So in this case theta 1 become 90 degree or pi by 2 and theta 2 become 0 degree. Okay, so from here you will get two field at this point. So one is this perpendicular component and second is this parallel component. So on putting the value you will get E perpendicular equals to k lambda by r sine theta 1 is 90 degree, so sine 90 is 1. So what we are getting, k lambda by r, and E parallel become k lambda 0 minus cos theta 1 is 90 degree, that's why 0 minus cos 0, and cos 0 is 1. So what we are getting, minus, since I am taking the magnitude so I can ignore the minus sign, it become also k lambda by r. So now how to add two vectors, one component k lambda by r, second component k lambda by r. So by using vector law of addition, so two vectors of same magnitude but perpendicular to each other, their resultant will be at 45 degree from each of the vector, and its magnitude is simply what we get 2 k lambda by r. So our field become, put the value of k, which is electrostatic constant, then electric field become under root 2 lambda upon 4 pi epsilon naught r. So which option is correct? Then this option is correct, because this is making 45 degree angle with the AP. In this question, we have to find the potential difference, and for that you have to remember the relation between field and potential. Field and potential. So relation between field and potential is VA minus VB is negative of integration B to A E dot dl. So since this is a uniform field, so we can write E B to A dl, and this will give the vector VA minus VB equals to minus E dot R AB. So just put the value, what we are getting, 2 I cap plus 3 J cap plus 4 K cap dot R AB. Now the question is how to find R AB. R AB is R A minus R B. So from here you will get 1 minus, from here you will get minus 1 I cap minus 3 J cap plus 3 K cap. Now simply VA minus VB, take the dot product of these two, 2 I cap plus 3 J cap plus 4 K cap minus I cap minus 3 J cap plus 3 K cap. So what you will get, dot product of this is minus 2 minus 9, and this is plus 12. So what we are getting, we are getting 1 volt. Oh, I forgot one minus sign here. I forgot this minus sign. So this become minus 1. Yeah. So in this question, what is given? The work done in slowly. Slowly, you have to focus on this word. Slowly means kinetic energy always remain 0. In lifting a body from the earth's surface to height r is equals to the 2 times the work done in lifting the same body from earth's surface to height h. So we know work done is work done is work done is change in potential energy. Work done by the force is change in potential energy, and work done by gravitational force is negative change in potential energy. So since we are calculating the work done by the external force, so it become final potential energy minus initial potential energy. So if you remember, the potential energy potential final energy when height is at r plus r, it become minus gm upon r plus r, because object is taken from earth's surface to the distance r. So initial energy when object is, this is initial energy, this is final energy. Initial energy and initial energy when it is at the surface, gm by r. So wa become gm minus upon 2r plus minus minus become plus gm by r. So from here we are getting gm by 2r. This is work done A. Now what they gave, the work done in lifting the same body from earth's surface to height h. Again what it become, work done In second case, change in potential energy. So on surface potential energy, on final height potential energies are gm by r plus h minus initial potential energy, that is gm by r. So what we are getting, minus gm upon r plus h plus gm by r. So from here what we will get, minus gm r minus gm r plus gm h upon r r plus h. So these term will cancel out. What you will get, gm h upon r r plus h. So according to the question, wa is 2 times the work wb. Wa is 2 times wb. So from here gm by 2r is 2 times gm h upon, this is r r plus h. So from gm cancel, r cancel. So what we are getting, r plus h is equals to 4h. So from here it become 3 3h equals to r, then h become r by 3. So our answer is this, r by 3. In this question, what is given? There is a current of 20 ampere. I is given. I is 20 ampere in a copper wire. Of how much? In a copper wire, radius is given. This is, sorry, this is the area of cross section. Area is 10 power minus 6 meter square. Okay, if the number of free electron, number density is given, 10 power 29 number of free electron per cubic meter. Okay, then drift velocity. So simply this is direct formula based. What we know, current is I equals to NEAVD. So from this relation VD become I by NEA. So just put the values, minus 6 into E is electron charge, electronic charge, 1.6 into 10 power minus 19 into A, into A. Sorry, A I have written already, N into N power 29. So from here, what you will get, uh, from here on calculating it, you will get VD equals to 1.25 into 10 power minus 3 meter per second. So which option is correct? Option C is correct. All right. In this question, what is given when the key is pressed at t equals to 0? The following statement about the current in resistor A. Okay, so what you need to remember, for DC supply at t equals to 0, capacitor behave as capacitor behaves as conducting wire, and at t equals to infinity it acts as open circuit. So what we have at t equals to 0, at t equals to, this is 2v 1000 ohm, sorry, this 1000 ohm. So at t equals to 0, current will not flow in this circuit. Current will flow to the less resistive part. Then current become simply voltage divided by 2 volt divided by 1000 ohm. So what you will get, I equals to 2 mA. And this is when at t equals to 0. This is not current at all times. At t equals to infinity, when it behave as an open circuit, our circuit will reduce to this circuit. This is 1000 ohm. This is also 1000 ohm. This is 2. So net resistance become 2000. So current become 2 upon 2000 ohm, which is 1 MA. MA means 1 MA means 10 power minus 3 ampere, 1 milliampere. Okay, so what is the answer? At t equals to I equals to no, this is not a correct answer because I is varying. I is not oscillating, its value will decrease. I is 1 MA at no, it is also not correct. At t equals to 0, okay. At t equals to 0, I is 2 ampere, yes, it is correct from this option, and with the time it goes to finally 1 ampere. So this is the correct option. So in this question, what we have to find? We have to find the equivalent of combination of capacitor. So in series, equivalent capacitance is C1 C2 upon C1 plus C2. In parallel combination, C equivalent is simply C1 plus C2. So if you observe carefully, 3, 4, these two are in 3 and 4 are in parallel combination. So their equivalent C34 become C3 plus C4 equals to simply 400 plus 200 is 600 microfarad. Now this C34 equivalent and C2 are in series combination. So their equivalent 234 become 600 into 400 upon 600 plus 400. So from here you will get 240 picofarad. Okay, this is also picofarad. All right. Now the equivalent of these three is in parallel combination with C5. So this is in parallel combination with C5. So our C2 3 4 5 become C2 3 4 plus C5. So simply 240 plus 240 plus uh, 240 plus C5 is how much? C5 is 200. So 200. So what we are getting? 440 picofarad. Now this entire combination is in series combination with C1. So their equivalent become, I am writing in the sequence C1, 2, 3, 4, 5. This become in series combination with the above equivalent. So 440 multiply C1 is 400 upon their sum, which is 840. So this will cancel out, and from here you will get the value roughly equals to 209.5. Now this entire combination, which combination? I'm marking it. This entire combination is in parallel combination with C6. So this is parallel combination with C6. So in parallel combination, simply C equivalent become C1, 2, 3, 4, 5. This means equivalent of 1, 2, 3, 4, 5 capacitor plus C6. So what you will get? 209.5 plus C6 is how much? 200 picofarad. So you will get 409.5. So the approximated value is 4110 is the closest answer. Here we have to find current in this resistor. So these points are grounded point, all have zero potential. So let's do one thing. Suppose current in this loop is I, and here current is I naught. So in this loop current become I minus I naught. Is it clear? Simply what we are doing, we are applying junction rule at point A. So we know KVL rule also. So applying KVL in, let's say this is our first loop and this bigger loop is second loop. So first apply KVL in first loop. So we know KVL rule is sum of all the potential differences is 0. So this is minus, this is plus, plus minus, plus minus, plus minus, and same for this plus minus. So apply KVL in this loop. So 10 minus 2i minus 2i minus I naught. Here we have to take this equals to 0. So what we are getting, 10 minus 4i plus, sorry, yeah, plus 2 I naught equals to 0. So from here what we are getting, 4, 2 we can take common. So you will get 2i minus I naught equals to 5. This is our equation 1. Now apply KVL in, this is in loop 1. Apply same for bigger loop 2. So 10 minus 2i minus equal, this sum of these two resistance or equivalent of this resistance is 6i naught equals to 0. So what we are getting, 6i naught plus 2i equals to 10. This is equation 2. Now what we need I naught. So what we have to do, just subtract second from 1. Simply second minus 1. So from here what you will get, 6i naught plus I naught, this 2 will cancel out, 10 minus 5. So what we are getting, 7 I naught equals to 5, and from here I naught become 5 by 7 ampere. So which option is correct? This option is correct. All right. Yeah. In this question, what we have given? We have given one dipole. Okay, A and B are the far point from dipole, and at a equal distance from it, the field A. So you you must remember the formulas of dipole. If this is minus q, this is plus q, right? And the direction of dipole moment is from plus to minus. So what you need to remember in this, these points are known as axial point. So A and B are the dipole at equal distance. Okay, A are the 2 points on the axis. Yeah, point A is on the axis and point B is on perpendicular axis. So on axis, electric field is in the direction of dipole, whose value is EA is 2 kp upon r cube, and on perpendicular bisector, electric field is in opposite direction. Opposite to what? Opposite to dipole moment, whose value is kp by r cube. So from here we can clearly see, if we write it in the vector form, both are in opposite direction. So what we are getting, ea is ea is 2 times negative of eb. So EA is 2 times negative of EB. So which option is correct? This option is correct. Okay. In this question, the charges are given to the identical metal plates of area this. The distance between the plate is d. Find the potential difference. Okay. So these are metal plates. Metal plates means conducting plates A and B. This is given 2q and this is given minus 3q. So what you need to remember in this case, distance between them is d. If you give charge to two parallel plates, then on outer surfaces, charge is average of the total charge. So this is, we know this is q1, q2, q3, q4. So here what we will get, q1 is equals to q4, which is average of the given charge, and average is this. So what we are getting, minus q by 2. And on inner plate, by using conservation of charge, on inner plate we have equivalent opposite charge. So q2 is opposite to q3. So what is q2? By conservation of charge, q2 is 2q minus q1. So it become how much? It become 2q minus q1. So 2q minus q1 is minus minus plus, it become q2. So 5q by 2. So same q3 is also, q3 become negative of minus 5q by 2. Okay. So let's make it again. On these two plates, what we have, this is q1, this is what, yeah, this is q1, how much, minus q by 2, this is also minus q by 2, on this side 5q by 2, this side 5q by minus 2. So in between, electric field is, at any point, electric field due to conducting sheet, electric field is only because of these two charges, because they have equal and opposite field, so field of outer charges will cancel out. So E net between the plate become electric field due to this plate and due to this plate. Due to this plate, let's say electric field is even in this direction away from the charge, and due to this plate it is also in the same direction, this is E2. So E net become E1 plus E2, that is, we know sigma by 2 epsilon naught plus sigma by 2 epsilon naught, it becomes sigma by epsilon naught. And what is sigma? Sigma is charge density, charge per unit area. So here we will have 5q by 2 epsilon naught. Now relation between field and potential is, potential difference is, if this is a point A, this is point B, so we know VA minus VB is into E into D. So potential difference become 5q by 2 epsilon naught D. So which option is correct? This option is correct. So what we can do in this question, the setup is given various resistor and batteries. So in this type of questions, generally we have to take one common point, or we can ground any point. So here potential becomes zero. Potential of this point is zero, and suppose, let's say, potential of this is zero. We are grounding this point, and potential of this point is x. So at B, what we can apply? Junction rule. So what is junction rule? Junction rule is sum of all currents through any junction is zero. So now we have four branches from here to here. We have four branches, one, two, three, and this is fourth branch, right? One, two, three, four. So what we can do? Sum of all currents. So current in first branch is, let's say, x minus 10 upon 4, plus in second branch x minus 10 upon, here we have registered 2. For third case, x minus again 10 upon 2, plus for this branch it become x minus 20 by 4 equals to 0. On equating this equation, we will get x equals to 35 by 3 volt. So what is x? X is the potential of point B. Potential of point B. Potential of point B is 35 by 2 volt. Now apply KVL from point B to point P. So in current in this branch is suppose I. So what we can do? 35 minus 20, 35 by 2 minus 20, this is potential, upon total resistor, which is 4 in this branch. So this will give us the value of current. So what we will get, what we will get from here, minus 25 by 12. It means whatever the direction we have assumed, that is incorrect, sorry, that is actual direction is opposite to it. So the magnitude of current become I equals to 25 by 12. And in which direction? Anti-clockwise. In anti-clockwise. Okay, so this option 25 by 12 is correct answer. In this question, we have to find the gravitational field of remaining portion. So we can say mass of a small portion upon total is mass is proportional to volume. So r cube, and here r by 2 cube. So from here what we will get? We will get 1 8. So mass of a small portion become m dash become m by 8. So remaining mass become m minus m by 8, which is 7m by 8. Now, and since x is very large than r, so we can say कि potential due to remaining field due to remaining portion become minus g m dash, sorry not m dash, m remaining upon m remaining upon x square. So minus e become minus e become minus 7 by 8 gm upon x square. So if you are taking the magnitude, what you will get? E will get 7 by 8 gm upon x square. In this question, we have to find the current through 5 ohm resistor, current through this resistor. So here we can see this is a parallel combination of cell, parallel combination of cells. So for parallel combination, we know E effective is E1 upon R1 plus E2 upon R2 upon 1 upon R1 plus 1 upon R2. By applying this formula, E1 is 12 upon 2 plus 12 upon 2 upon 1 upon 2 plus 1 upon 2. So here we will get 12 volt, right? Now this is E equivalent. R internal resistance equivalent is 1 upon 2 plus 1 upon 2. So this will give you R equivalent equals to 1 ohm. Now what setup we are getting? We have one equivalent battery of how much? Of 12 volt and 1 ohm resistor, and we have one another 5 ohm resistor. So current in this branch become I is 12 upon total resistor, which is 12 by 6. It will give us 2 ampere. So answer is 2 ampere. So here, if this is in equilibrium, then from here we can write T sine theta is equals to F, and F is what? F is electrostatic force. So which is K Q square upon X square. And second thing, vertical component is also balanced, so T cos theta is mg. So from here, what we are getting? We are getting tan theta is equals to K Q square upon X square mg. So what we need to remember here, x is very less than L. So we can say theta is very small. We have to apply this assumption here. Theta is very small. So for smaller values of theta, sine theta and tan theta all are almost equal. And from this triangle BMA, from in triangle BMA, sine theta is x by 2 upon L. So what we can write? X by 2L, which is also equals to tan theta. Now putting value in equation 1, putting value in equation 1, what we will get? X by 2L is equals to K Q square upon X square mg. So x cube we are getting K Q square. Value of K is 9 into 10 power 9. Value of charge is how much? 10 power minus 10 into 10 power minus 10 upon uh, into, we also have into 2L. L is how much? 300 centimeter. So 2 into, directly I can write 3 meter upon mg. Mass is 20 into 10 power minus 3 into g. G is 10. Okay. So from here what we are getting, we will get x cube equals to x cube equals to x cube equals to 27 upon 10 power 10 meter cube. And what we have to convert it, we have to convert it into mm cube. So how we can convert it into mm cube? By simply multiplying by 10 power minus 9, because in 1 mm we have 10 power minus 3 meter. So from here we will get 27 upon 10. So I'm writing here, so x become 27 by 10, 1 by 3, so which will give us x equals to 3 by 10 power minus 1 by 3 mm. So which option is correct? Option B is correct for this question. Okay, moving to the next question. Okay, the longer side of a rectangular is twice the length of the shorter side. A positive charge Q is kept on the one vertex. The maximum electric potential due to that charge at any vertex is T. What we have to find? Minimum potential. Okay, let's make a square. Sorry, this is a rectangle. This is A, this is 2A. If we have charge Q here, okay, then all right. So potential due to point charges K Q by R means V is proportional to 1 by R. V is maximum when A is minimum, when distance between two vertices is minimum, and V is minimum when distance between two vertices is maximum. So maximum potential is here. Maximum potential, max potential is B equals to KQ by A. Now talking about minimum potential, so if you check, this is, this separation is 2A, this separation is A. What diagonally opposite vertex? This is at how much? This is at under root 5A. This is under root 5A. So potential at, this is OAB. Potential at B, potential at B is minimum. So what is the potential at B? We can write KQ upon under root 5A. So what we are getting? We are getting V by under root 5. So this option is correct. All right. Moving to the next question. The insulating solid sphere of radius r, all right, is uniformly is non-uniformly charged, whose volume charge density is given. So in this question, volume charge density is not constant. Volume charge density is r equals volume charge density is rho equals to a by r. This is rho equals to a by r. This is printing here, where A is a positive constant, R is the distance from the center. Electric field is strength at any point. So what we know, suppose this is a insulating solid sphere, this is solid sphere, and what we have to do, we have to find electric field at this potential, at this point. So let's make a Gaussian surface. So what we can do at this point, which is at r distance, this is r, electric flux is E dot dA equals to q in by epsilon naught. So electric field is symmetric, so we can write E into 4 pi r square, r1 square, okay, equals to q in is charge inside this sphere. We have there is no need to calculate total charge. What we have to find? Charge inside this sphere. So charge inside this sphere is a sphere of sphere of radius small r, which we can find q in by epsilon naught. Q in is rho 4 pi r square dr. 4 pi r square dr. This is We are taking a small spherical shell element, and rho is how much? A by r into 4 pi r square dr. R will cancel out 0 to r1. So what we are getting? We are getting 4 pi a, 4 pi a, and integration of r is r1 square by 2. So put this value in this equation. So what we will get? 4 pi a r1 square by 2. So 4 pi r1 square, 4 pi r1 square cancel out. What we will get from here, I'm writing in here, we will get E equals to a by 2 epsilon naught. E by 2 epsilon naught. Okay. Question number 45. The double star is a system of two stars rotating about the center of mass only under the mutual gravitational attraction. Okay, let's the stars have mass m and 2m and their separation is L. The time period of rotation about there will be proportional to. So, okay, so suppose this is a double star, okay, and their center of mass is somewhere here. This is m, this is 2m, so sorry, center of mass is closer to bigger mass. Center of mass is somewhere here. This is r1, this is r2. So from here what we can do is uh, centrif- centripetal force on it is equals to gravitational force, and gravitational force is how much? Gm to m upon this total distance is L. L square equals to m m omega square r1, and r1 we know r1 is how much? 2m upon m plus 2m into L. So what we are getting? 2 by 3 L. Okay, so here r1 2m square upon L square equals to m omega square. R1 is 2 by 3 L. So 2 will cancel out, 1 mass will cancel out. So what we are getting? Omega square equals to g m 3gm upon L cube. Omega become 3gm by L cube under root. So time period is, we know time period is 2 pi by omega. So 2 pi upon omega become under root 3 gm by L cube. So we can write it like this also, 2 pi L cube upon 3 gm. So time period is proportional to L to power 3 by 2, and time period is also proportional to m power minus 1 by 2. So which option is correct? It is proportional to L power 3 by 2. In this question, the linear charge density on a dielectric ring is varies as theta. So in this question, charge density, let's check this. I'm making the diagram. So at any point charge density is, so charge density is lambda equals to lambda naught cos theta by 2. So what we have to calculate? Potential. So potential due to a small element, let's take this element at angle theta, and this small angle is d theta. So this arc length become r d theta. So dq is small element, this is a small element, which is dq become lambda r d theta, and lambda is given how much? Lambda naught cos theta by 2 d theta. So what is dv? Small potential at center due to this element is k dq by r. V is integration of k dq by r 0 to 2 pi. So just put the values. V equals to k dq is lambda naught cos theta by 2 d theta by r 0 to 2 pi. So integration of cos theta by 2, we will get integration of cos theta by 2, integration of cos theta by 2 we will is sin theta by 2, and if you put the limits 0 to 2 pi, what we will get? We will get 0. So total charge is 0, then potential become 0. In this question, 3-point charges are 2q, 2q, 8q are placed on a 9 centimeter long straight wire. The potential energy of the system is minimum possible. So what we have to find? Okay, how many charges? This is q, this is 2q, and this is 8q, right? So let's say separation between these two charges is x. Then separation between these two become 9 minus x. Why? Because total separation is 9 centimeter, right? So what is the potential energy of this system? Potential energy of this system is, let's mark the number of charges, 1, 2, 3. So total potential energy is potential energy interaction between 1 and 2 plus 1 3 plus 2 3. So what is potential energy? Potential energy between two charges is k q1 q2 upon separation between them, right? So for u1 and u2, what we will get? K q 2q upon separation is x. Between 2 and 3, k q 8q upon separation is 9 plus k, now 2 and 3, 2q 8q, and separation is 9 minus x. This is u total. And potential energy is minimum or maximum when? Minimum when du by dx is 0. When du by dx is 0. So now what we have to do? We can differentiate it. We can differentiate it. On differentiating, what we will get? Okay, let's differentiate it. Du by dx total minus, we can take k q square. Okay, let's take it as it is. 2, differentiation of this become minus x square minus 0 plus differentiation of this become k 2q 8q upon 9 minus x square, and this minus minus become plus. So from here what we are getting, this is equals to 0. So on solving this equation, we will get the value of x. On solving it, on solving, we will get x equals to 3 centimeter. So in this question, what is given? The planet revolves around the sun in elliptical orbit. The aerial velocity is given, and what else is given? The least distance between the planet and sun is also given. The maximum speed. So we know when the distance is least, speed is maximum. And also we know dA by dt, aerial velocity is L by 2m. So from here what we can write? L is 2m into dA by dt. What is L? L is angular momentum, and at the minimum distance, angular momentum is mvr equals to 2m dA by dt. So m will cancel out, v become 2 dA by dt upon r. So just put the value, 2 upon r is how much? 2 into 10 power 12, and aerial velocity is 4.0 into 10 power 16. Okay, so what we are getting, this will cancel out, yeah, this is 16, so we are getting 4 into 10 power 4. So but the answer they are asking kilometer per second, so it become this is meter per second. When you convert it into kilometer per second, you will get 40 kilometer per second. All right. So in this question, the two capacitors are given. C1 is 2 microfarad and its maximum voltage is Vmax is 3 kilovolts. So here what we can calculate? We can calculate its maximum charge holding capacity. So Q1 become CV. So it become 2 into 10 power minus 3 into 3 into 10 power 3. So what we are getting? 6 coulomb. Similarly, what we are getting? Another capacitor C2 is 3 microfarad and its Vmax is 4 kilovolts. So its maximum charge which it can hold is 12 coulomb. Now what they did, they connect these capacitor in series. And what is the maximum voltage? Okay, all right. So what you have to remember in this is, suppose if you connect this with battery B, this is capacitor C1, this is capacitor C2. So in series combination 1 upon C equivalent is 1 upon C1 plus 1 upon C2. So from here 1 upon 2 plus 1 upon 3, which is 5 by 6. So C equivalent become 6 by 5. Right? Yeah. Okay. So if you connect two capacitor in series, charge remains same. Charge remain same in series combination. So whatever charge this capacitor have, the same charge will have on this capacitor. So now the question is, what is the maximum capacity of charge Q1? Sorry, capacitor C1. So maximum capacity of this is 6 coulomb. So we can say that total charge on the system remain 6 coulomb. So 6 coulomb charge remain on the entire system. So for this combination, what we can calculate, V is V is Q equivalent by C equivalent. So Q is how much? 6. C equivalent is 6 upon 5. So from here what we will get? 5 volt. So answer is 5 volt. Okay. Now coming to this question, four equal masses each of the side M is given on the corner of side A. So what we have to find? Escape velocity. So how we can find? Suppose this is the square and four equal masses. So if any mass M is placed on the center, we have to find escape velocity from here. And how we can find escape velocity? So escape velocity means we have to give minimum energy, minimum kinetic energy, which can take this particle to infinity. So at infinity we are assuming kinetic energy is also zero. because we need escape velocity, minimum velocity. So total energy is 0. Now the question is, what is the energy when particle is at point O? So at O, particle is having kinetic energy at O. It is having kinetic energy plus potential, gravitational potential energy. So suppose we give E initial half mv square. Potential energy we know is, potential energy between two masses is G m m upon separation. So this separation is how much? A by under root 2. If this is A, this is A. So we will get A by root 2. And since this energy is due to four masses, 1, 2, 3, 4, so we have to multiply it with 4. So half mv square minus 4 root 2, 4 root 2 gm m by a. Now we know no non-conservative force is acting on it, so E initial is equals to E final, conservation of energy. So what we will get, half mv square equals to 4 root 2 g m m by a. So m cancel, v is under root 8 root 2, 8 root 2 gm by a. So now comparing with this equation, from here what we are getting, x is 8 and y is 2. So x minus y become 8 minus 2 equals to 6. So correct answer of this question is 6. Simply you have to conserve the energy.